Good morning. So today I will continue doing the usual problem solving that I usually do, but this time I'm going to do it on HackerRank rather than Code Wars. And this is only because I have a good friend and an inspirational developer from Mauritius who uses this website, so I will be using it as well. And here I'm just looking at the preparation problem solving part. In terms of algorithm, there is also data structures to the array left rotation dynamic array. That's all awesome and easy. Medium, this one is pretty good, but let's start with something very easy just to warm up. Compare the triplets. So why not this one? Easy problem solving, basic, max score 10, a success rate, so solved. So actually did that before. Of course, I haven't been using HackerRank for a long time now, and let's say how. Apparently, HackerRank is suggesting this one. There's so many greedy algorithm, warm-up implementation, so on, so recursion, game theory, constructive algorithms. So there is a lot of. Let's try this one. I've actually even forgotten how it works. Yeah, I remember reading it, but I didn't attend it even, so I'll be using Ruby because I use Ruby at work, and I think this is a good opportunity to improve on the language. So what is happening right now? Alice and Bob each created one problem for HackerRank. A reviewer rates two challenges, awarding points on a scale from 1 to 100 for three categories: problem, clarity, originality, and difficulty. The rating for Alice challenge is a triplet bang, and the rating for Bob's challenge is a triplet. Okay. The task is to find the comparison points by comparing A0 with B0, A1 with B1, and A2 with B2. If A1 is bigger than B1, then Alice is awarded 1 point. Otherwise, Bob is awarded 1 point, and if it's equal, neither person receives a point. Comparison points is the total points a person earned given A and B determine the respective comparison point. Wow, that's pretty long. That's one of the biggest difference I've noticed uh, between HackerRank and Code Wars. Code Wars can literally give you, here's the input, here's the output, we want you to do that. Bang, it's over. Done. While HackerRank usually tell a story about how you want to solve it, like we are seeing right now. So okay, let's understand the example. A 1 to 3, B 3 to 1. For elements 0, Bob is awarded a point because A index 0. Okay, I understand. For equal elements, the points is our earn. Finally, for elements 2, that is A2 is bigger than, so Alice, of course, they just explained it above. The return array is 1 1 with Alice goes first and Bob goes first. Okay, so it can be a good opportunity to solve it, but first I'm just going to map the return values. And from the input and return, I will build the process, the problem in between. So let's take this example itself. Good starting point. So return value is Alice first, then Bob. Alice here, Bob here. So yeah. So let's try in this example. So the first one we have 1, 2, 1 and 3 is a 4. It will be 0 in my opinion, 0, 1. So we go to the second index, 2, 2, but nobody gets an increment, so it stays the same. Then finally we have what I'm doing here. Don't even need this, just an example, 3 and 1. Okay, this is actually very easy thing, but by first we've just read the description, it already makes sense. But if you just start with an example input and an example output, we usually call that sample. Then we have something like that. So that's the operation here with +1 bob, bon, bob. Then we have plus, it's 0 both, it's 0 actually because they are the same. Then we have here 3 1, it's +1 for Alice. Alright, so it looked very good. For now, let's focus on the codes. But before, let's think what is one way of doing it. Let's solve it a type of, I mean, mentally, pseudocode, just go for it. So we just need to loop. So I'm just assuming that these two arrays always have the same amount of indexes. So we just loop a single array. I mean, we just get the length of one of them, or maybe we can manually take them because two challenges. The viewer rates the two challenges, awarding points on a scale of. So let's say is the triplet A. So here it seems as if we do not. So I'm just thinking: is it always the same? Do we always have three? The array's length is always 3, or is it something else? Sample input, we have another input here. So here we have the mathematical part. So it seems as if it is always the same. So we have constraint that we need to surely check. This in this case is just a matter of God clause. But since it's an array, of course, we need to think about how to do it. It seems the length is always 3. So what am I going to do here? Let's just use some principle here. I can just start make the code as dumb as possible. Yeah, maybe that's a good way to start, just to make the code as dumb as possible. But of course, we can loop it later. Just take the first one, compared to the second one, and it won't be too interesting to be honest. Let's see. This is Ruby. Ruby is like English. So let's say I can do something like A0. One thing I really like with HackerRank though is that you get this syntax highlighting, which is absent on code was, and whenever I was practicing C# codes before, it was a bit tricky because you don't really know what's going on in behind. Sometimes you make some very, very simple syntax error and it doesn't get highlighted and you just waste time trying to debug it. So I can do something like this, P0, and finally we have, if this is the case, then A should be plus plus, something like that. Alright, so Alice, Bob, and just like that. So just to make it a bit clearer, at first I'm just going to be writing some dumb codes with clarity in mind. So let's say Alice 0, Bob 0. Okay, so I could have used an array like that and just give the index. So let's use it very simple at first. And it's highlighting, so useless. Yeah, so I think we are using Robocop behind. Robocop is a type of linting and style. It checks the style. So okay, this is very good. This is our return results. So I will see later on how to deal with if we could use God clauses, but not right now. Let's write it as simple as possible. Because I could do it really well, optimize in a single go, but then I am also recording this video and explaining at the same time, so maybe I'm taking a bit too much time to explain this. Let's go a bit quicker. So we assume that it's going to be the same. Like the length count, array count. So ici, count, let's see count. Or I just take it. I'm just thinking a dot. We filter. Just checking the loop. How to loop. So there's several ways we can just do it. I'm just checking out the easiest way. Okay. Each we can use each with index. Then we have our block element. So a block is a bit similar like lambda for others in other programming language. So item index. So we have this, and just we need to put our n ourselves. Therefore, we are going to be looping in A. And where is this? So in Ruby, we don't really have. Well, it's not the traditional for, the for I for like you would do with Java or C Sharp, the traditional imperative type of code, procedural or imperative type of code, because Ruby really inspires itself from Smalltalk, Prolog, like a bit more functional programming. That's why it's different. So yeah, we are going to just compare it. If if A, so it's item. We don't even need to do all of that actually, but I'm just writing it as dumb as simple in my mind, just to make sure that it's going as simple as possible, so that I can easily explain, and at the same time we will obviously be improving it. So there are two ways. Can say item or index as well. So say item is bigger than b at index. Then end if it's a is bigger than b elements, so we will just put Alice and increment it plus plus. I don't even think if it works. Actually, we don't have this in Ruby as well. We need to write something like that. So what I was for example, the incrementer, we don't really have this incrementer in Ruby, and rather I'm just confirming on Google. I think it's the same for Golang and other programming language, but yeah, we don't have this shorthand notation. It's just the traditional one. Now, okay, if this is bigger, else, because we have only two conditions. But what happens if they are? So we cannot just do it like that. So item is smaller than b index, the same thing. Then it's rather b index. That's going to be incremented by one actually. So it's not even working like I was. And else, so we have another condition, do nothing. So actually we don't even need to write the else because it is not going to do anything. So here we have the solution right now, and theoretically should work. Just return an array with Alice and Bob. So here we are just changing the element directly because in Ruby, like most programming language, it's referenced by its parameter by reference. So we are actually we are not when we do that change here, it's going to go directly in the memory and change the value. rather than the reference to the value. But this is not good practice in functional programming type of languages, but this is outside of the scopes, and it's good to do. So in Ruby, if the last element, you don't need to put the you don't need to put the return key. Let's see. So run code. What happens? I've forgotten how it works. It's been so much long time that I did not use HackerRank. And maybe I should actually be using, so it's wrong. Ha! It's wrong, and your output is this, expected output is this. So yeah. So we can actually debug it. Alright, we are just using each, and for each A with each, so we are looping through A, and we then compare if it's working. So this can be a good opportunity for debugging. We have this input, we have this output, and the output should be 0, 1, 0. It should be 1, 1. Of course, it's 1, 0. So we already see right now that Bob is B. Bob is not. It's not working. So item, maybe this should not. Of course, should not be this one. So I just explain some. I just written this because I wanted to explain something in behind, I think. So let's just run the code. It should work without any issue right now because I was assigning the wrong data. It takes quite some time, so it works actually. And now let's say we wanted to simplify. We did not even take the God clauses into consideration, but I assume it's true. So let's say we wanted to simplify this item, this solution. What can we do? In my opinion, we can use. I think it's very simple. I'll just submit the code this time. Now we have a more difficult one, obviously. For the run code, they just gave us the simplest code. So in reality, this is a very, very easy exercise. Just warm up, and normally you can just do it in a matter of minutes, like 2 or 3 minutes, if you like the coding itself. So wow, it's beautiful. This I didn't know that, but I don't know why you have earned your first star. Continue. Because the reality is that I've solved such type of problems before. So alright, so this is the first video. If I have some time, I'm going to be recording another one.